Welcome to qnawire.
So we need to find the total outward force of the molasses, and we have to set up an integral here. We know that force can be defined as the integral of the pressure times the change in area. And here, because the molasses is exerting a force around the essentially the perimeter of the cylinder, we can say that the area here is going to be the perimeter, or rather the circumference of a circle. Of course, this being 2 pi r. So given this, and knowing that the pressure is equaling the density of the molasses times the acceleration due to gravity times the height, or we'll call it y, the height of the cylinder, we can further define this integral. We can say that f is now the integral of the density of molasses times the acceleration due to gravity times y, and then here we'll have 2 pi r, the circumference of that circle, or the outer ring, essentially, one layer essentially of the ring around the cylinder. And then we'll have dy, because we're trying to integrate this over the entire cylinder. So we actually have a bit of some constants here. We can say that the force, again, is equaling 2 pi times the density of molasses times the acceleration due to gravity times the radius of the cylinder. And then we can integrate from 0 to h, the full height of the cylinder, of y dy. We know that this is going to equal 2 pi times the density of molasses, the acceleration due to gravity, the radius of the cylinder, and then y squared over 2 evaluated at 0, and then h being 17.7 meters, where h equals 17.7 meters, or the full height of the cylinder. And at this point, we can simply plug in for our knowns. So we have 2 pi. The density of molasses is going to be 1,600 kilograms per cubic meter. And then 9.8 meters per second squared is the acceleration due to gravity. The radius here is going to be the 27.4 meters divided by 2. And then, of course, at 0, this is going to equal 0. But at 17.7 meters, we have 17.7 squared over 2. And solving for this, we know that the force is going to be equal 2.11 times 10 to the 8th newtons. So again, in order to have done this, we had to have integrated, because they want the total force. And if we integrate on a very, very small ring, or a very small ring of the cylinder, or simply the circumference of a circle, essentially, and then we integrate it from the bottom of the cylinder to all the way to the top of the cylinder, 0 to 17.7 meters, we will end up with the total pressure that the molasses is exerting on the cylinder. And again, that final answer is 2.11 times 10 to the 8th newtons. And that's the end of the solution. Thank you for watching.